Last video, electron configurations of ions. This is something that should be simple, and people get it wrong a lot, and it drives me insane. This zinc +2 ion, make note of this. It's on one of your tests. Throughout the year, I'm not going to tell you what test it is, but one of the chapter tests will ask you for the electron configuration of a zinc ion, and I bet over 50% of people will get it wrong, and it drives me insane. This is not supposed to be bad. This should be like an easy question where you're like, yes, fist pump, I'm going to get this right. First thing I'm going to do is label my periodic table. I'm going to number it from 1 to 7 down the side. This one's already done. That's the S block. There should be an S orbital in every energy level. When I get over to the P block, I'm going to start numbering it 2, 3, 4, 5, 6, 7, because the P's don't start till the second energy level. In the middle of the D block, the D's don't start till the third, so I'll start numbering 3, 4, 5, 6. And if I felt really wild and crazy, the F block at the bottom, the F orbitals do not start till the fourth energy level. So this is the 4F and the 5F. Cool. Okay, that took me all of 2 seconds. And it's well worth my time. I think here's the problem. People just forget what happens when you form an ion. They just turn into boneheads when it comes to ions. So for example, selenium. Selenium is element number 34. 34 should be kind of down in this region right in here. Selenium, kind of hiding behind the P. There's my friend selenium. If I were doing the selenium atom, selenium is number 34. I'll write that in there, kind of. 34. I'll put a note on here. Selenium atom is element number 34. There should be 34 electrons. But this is not the selenium atom. This is a selenium ion with a charge of 2 minus or minus 2. So I have to know what that means. Oh, 2 minus, minus 2? That means I have 2 extra electrons. So this selenium 2 minus or minus 2 ion, I need to draw out an electron configuration with 36 electrons. Well, that's not so bad. In fact, element 36, it's going to look like krypton. Well, that's kind of the point of forming an ion. Ions are stable. They've gained or lost electrons to get full outer shells. So when you do an electron configuration for an ion, don't be shocked if it looks like a noble gas. Okay, so now the next question that people ask, can I just do this? Could I just say, oh, cool, element 36, krypton. Could I just put krypton in brackets and be done with it? Possibly. But they may ask for it in long form. Ah, smart. So if they don't specify and you want to put krypton in brackets, go crazy, that's fine. But they'll probably say in long form, which means start at the beginning. Oh, cool. Okay, so they'd probably ask for it this way. 1s2, 2s2, 2p6, that gets me 10 electrons. 3s2, 3p6. Now instead of going right to the 3d, that 4s sneaks himself in there because he's lower in energy. So I'd say 4s2, then I hit the 3d, it goes across 10. And again, now here's what I love. I love having this marked in. This was the 4s, the 3d. Now it goes back to the 4p. Oh, cool. 4p, I need to go across 6. 4p, I'm going all the way across 6 for the selenium ion. If it was just the selenium atom, it would end 4p4. But the selenium ion will gain 2 electrons, and I should have 36 total. So humor yourself and mark up that stinking periodic table, Because so often people will forget that you're back to the 4p, and they'll write 3p. Oh, wait a second, you already filled the 3p. This is the 4p. Our friend Zinc. I promise you, this Zinc plus 2 ion configuration, this is totally on a test. I'm not going to tell you which one, but it's on one of the tests. Zinc is element number 30. So he's actually kind of right in here. Zinc number 30. Okay, cool. So zinc plus 2. Zinc plus 2 means to lose 2 electrons. Oh, be careful, be careful. How can I write caution? Yikes. So it's not smiley, it's not sad. It's just a be careful. Okay, let's do the zinc atom. Zinc atom. Number 30. 30 electrons. Let's look at the zinc electron configuration. 1s2, 2s2, 2p6. That's it for the second energy level. Next comes 3s with 2. I follow it across to the 3p for 6. Finally, I'm in the right row. 4s2. Zinc is 3d, 10. Do I have 30 electrons? 2, 4, 10. Yep, 20, 30. Okay, so here's the zinc atom. And you could also have this in a shortcut. This would totally be acceptable. 30 electrons. If I go backwards, I would shorten this up with argon. And then all I have to do is start with 4s2, 3d10. Both are 1,000,000% acceptable. Okay, so here's the most common wrong answer. People are like, I get it, I'm super smart. Plus 2, 2 plus means to lose 2 electrons. All right, so you know what they do. They go like this. Okay, so here's the zinc atom. That was zinc atom. This is going to be sad face. Don't do this. They do this. 3d8. I'm serious when I tell you that on the test, more than 50% of you will probably get this one wrong. For a few reasons. Reason number one, they'll do the zinc atom. They'll do 30 electrons, and then they get it back, and they're like, oh, dang, I suck. Just for that moment in time. I'm really a nice person. The other fraction of people that get it wrong are close. They knew to lose 2 electrons. They took away the wrong 2 electrons. When you lose electrons, you always lose electrons that are furthest from the nucleus. Think about it. You want to lose the electrons that are farthest from the nucleus because they have the least attraction to the nucleus. They're further away, so that attractive pull between the positive nucleus and the negative electrons is weakest. You're not necessarily losing the electrons at the end of the electron configuration. You're losing the 2 electrons that are farthest from the nucleus. Oh, isn't this tricky? Here's the right answer. Ding, ding, ding. Happy face. Argon 3d10. It's these guys. Those 4s electrons are further from the nucleus than the 3d electrons. You're going to lose the electrons that are farthest from the nucleus in the highest energy level. And I get it, it's tricky. But you're not losing the electrons that are at the end of the electron configuration. So you have to think about this conceptually. Lose the electrons in the highest energy level. The electrons that are farthest from the nucleus. So you're going to lose those 4s2 electrons. That's why zinc is most commonly a +2 ion. Like 99% of the time, zinc is +2 because he has 2 electrons in that 4s orbital. Well, he's probably just going to lose both of those 2 electrons. And then his 4th energy level is empty. All of his electrons are in the 3rd electron, or the 3rd energy level. You like that, don't you? And you can totally see how people get that wrong. So make yourself a little mental note. When you have a positive ion and you're losing electrons, lose them from the outermost orbital, the ones that are furthest from the nucleus. And if they ask you why, which they probably will, it's because they would have the least attraction. They're furthest from the positive nucleus. They'd be least attracted to the nucleus. They should be easiest to remove.